Hello everyone, welcome back to my YouTube channel. In today's video lecture, we will be covering some important questions that you need to know about the set theory and how those questions will be solved. So in this screen, first of all, you are seeing some important formulas that you need to remember. You just write it down somewhere, and we will be solving question on using these formulas. First one is your A. First one is your A union B. Second one is your for A minus B. Third one is B minus A, and the fourth one is for the union of three different sets. Now coming on to the proof, how to prove that A union B equals to B union A. We all know that this is a commutative law, as set follows the commutative law. But how can we prove this? So the first step to prove LHS equals to RHS in set theory is that let X be any element of LHS. Whatever the LHS is, just let that X belongs to that particular LHS. So the first step is this. Then just open up the bracket, and if there is union, you can write it like or. For union, you will be writing or. For intersection, you will be writing and. Remember, this is not always true. You need to apply some logical thinking while opening up the bracket. See, if we have union, that means either X belongs to A or X belongs to B. In both of the cases, the X belongs to the union also. If we have A 1 comma 2 and B 1 comma 3, then in A union B we will be having 1, 2 and 3. So suppose we have 1 as an X element, then we can say either X belongs to A or X belongs to B. One of the condition must be true in case of or. Then we just write like firstly we write X belongs to B and then X belongs to A. Why we do that? Because we need to prove that X also belongs to B union A, which is the right hand side of the proof. If we prove that, then we can say A union B LHS is the subset of RHS. Firstly we prove that. Second, start taking another element and prove that Y belongs to B union A. Just open up the bracket here also. Y belongs to B or Y belongs to A. Then we just swap these Y belongs to A and Y belongs to B, and using this we can say Y belongs to A union B. This is how we can say B union A is also a subset of A union B. So from 1 and 2, if A is a subset of B and B is a subset of A, then we can say these two sets are equal. So from 1 and 2, we can say A union B equals to B union A. Now let's see another proof. Suppose we need to prove these three terms. A minus B equals to A intersection B dash equals to B dash minus A dash. In this case, let's start with X. Firstly, we will be starting from here. X belongs to A minus B. If X belongs to A minus B, that means X belongs to A, but it does not belongs to B. Both of the condition must be true. So we will be writing and for this condition. So X belongs to A and X does not belongs to B. We can say X similarly we can say X belongs to A and X If x does not belongs to b, then it definitely belongs to b dash complement of b. So this is why we wrote it down. So using this equation we can say x belongs to a intersection b dash, because we know and is used for intersection also. So here we proved that a minus b is a subset of a intersection b, which is this part, middle part of the proof. Now let's say y belongs to a intersection b dash. Here we can say y belongs to a, and for intersection we can write and y belongs to b dash. If y belongs to b dash, that means if y belongs to complement of b, then it does not belongs to b. We can just replace it using this, and this is the equation for like y belongs to a minus b, because y only belongs from a and does not belongs to b. So we can write it like y belongs to a minus b. So here we proved that a intersection b is a subset of a minus b. So from 1 and 2 we can say both are equal. Now we need to prove a minus. If we prove any like we proved this equals to this, now we prove this equals to this. So let's start from here. Let's say x belongs to a minus b. For that we can write x belongs to a and x does not belongs to b. We already proved that. If x belongs to a, then it does not belongs to the complement of a, definitely. So this is the another implication. Now if x does not belongs to b, that means x belongs to complement of b. So we wrote it like this, and just swap this here, add one more step. X belongs to b dash and x does not belongs to a dash. It means x belongs to b, but it does not belongs to a dash. So we can write it like b dash minus a dash. So here we proved that a minus b is a subset of b dash minus a dash. In the same way, second part will be y belongs to b dash minus a dash, which can be written as x belongs to b dash and does not belongs to a dash. Then just write it like x belongs to does not belongs to b, and this implies if x does not belongs to complement of a, then it definitely belongs to a itself. So we can say here, just write it like x belongs to a and x does not belongs to b. This is like x belongs to a minus b. So here we prove that b dash minus a dash is a subset of a minus b. So this equation and this equation proves that both are equal. So this is how we prove the let's take another example. This is the most important, as it is the De Morgan's theorem. Sometimes the question is state De Morgan's theorem and prove it also. So you need to just remember it, De Morgan's theorem. So the first step again is x belongs to the LHS. So just open up the bracket. If x belongs to the complement of A union B, then it does not belongs to the A union B. First step is this. Then just open up again. What does it means? If there, for example, A is 1, 2, B is your 3, 4, and A union B will be 1, 2, 3, 4. If suppose we take an element like 5. 5 will be true for this case, as 5 does not belongs to the union of A and B. So what does it means? It implies that 5 does not belongs to A and 5 does not belongs to B. Both should be true. So that's why we didn't replace this union with or. We replaced this union with and, because both of the conditions will be true in this case. X does not belongs to A and X does not belongs to B. What does it means? If X does not belongs to A, that means it definitely belongs to the complement of A. And if same with B also, then we just write it like X belongs to A dash, this and is intersection, and this again B dash. So X belongs to A dash intersection B dash. That it implies that A union B intersection is a subset of A dash intersection B dash. Now another step will be like, let's take another element which belongs to RHS. Then open up it also, that if y belongs to A dash intersection B dash, then y belongs to A dash and y belongs to B dash. In this case also, if y belongs to complement of A, then it does not belongs to A, and if y belongs to complement of E, then it does not belongs to B. And for this we can write like y does not belongs to, if this is the condition, then y, if y is an element that does not belongs from to A and also to B, then it definitely does not belongs to its union also. So this is how if it does not belongs to the union, then we can say it belongs to the complement of union. So this is how we proved here that A intersection B dash is a subset of A union B whole complement. So we can write like from using 1 and 2, we can say the LHS equals to RHS. Let's take another example, another question. Here we have this equation where we need to prove this. Again the steps will be like, take the element from that belongs to LHS and prove that it also belongs to the RHS. So here also, let's start with X belongs to A minus B intersection C. Then this will be written as X belongs to A and X does not belongs to B intersection C, because for A minus B we write like X belongs to A and X does not belongs to B. So here B is replaced by B intersection C. Next we'll open up the bracket here, like this will remain same, X belongs to A, and what does it means? That if X does not belongs to B intersection C, then definitely X does not belongs to B and does not belongs to C. So we just open up it like this. Again we can write like X belongs to A and X does not belongs to B, and X you can write it multiple times. There will be no restriction on this. So again X belongs to A and X does not belongs to C. Then this bracket will be written as X belongs to A minus B, and this bracket represents X belongs to A minus C. Again, if X belongs to A minus B and X belongs to A minus C, we just replace it with and this and will be like the RHS. So this is how we prove that LHS is a subset of RHS. In the same way, you can prove RHS is a subset of LHS, and so using equation 1 and 2, you can say that LHS equals to RHS. Let's see another example. Here we need to prove A union B equals to A minus B union B. Again, first step will be X belongs to the LHS. For union, we will be replacing it using OR. Again, X belongs to A or X belongs to B. We can write X belongs to B or X belongs to A, and just add the condition where X belongs to B or X does not belongs to B. In this bracket always remain true because one of the condition always exist. Either X belongs to some set or X does not belongs to that set. So here why we take this condition, because we need to take union with B. So that's why we took this condition. So now we can say X belongs to B, X belongs to A, and let's say X, because X belongs to B and X belongs to B is common, so just we took it for once, and X does not belongs to B. Using this we can say just take this bracket and we can say X belongs to A minus B. Again just swap the sequence, so we can say here X belongs to A minus B or X belongs to B. So OR represents union here, so this is the RHS itself. This represents that LHS is a subset of RHS. Again take another element that belongs to the RHS. This is the RHS. So just open up this bracket. We can write Y belongs to A and Y does not belongs to B, or for union or and Y belongs to B. So just swap the sequence. We write Y belongs to B, or Y belongs to A and Y does not belongs to B. So open up the bracket. Y belongs to B, or take this as one bracket, and in another bracket just take Y belongs to B or Y does not belongs to B. Again this will be commutative, so we can write Y belongs to A, Y belongs to B, or with or, and Y belongs to B, B dash, or Y belongs to B. Again we can write Y belongs to A, or, because this will be always true, so we don't need to write it separately. So here we have Y belongs to B, so Y belongs to A union B, which shows that RHS is also a subset of LHS. So here also we prove that both of the LHS and RHS are subset of each other, so LHS equals to RHS. Now let's solve one question where set A, B, C is given and universal set is also given. So let's solve these parts. First one is A union B. A union B, of course, in the result we will be having all the sets of A firstly, that means 2, 5, 8, 10. Then all the sets of B, but remember no repetition is allowed. So we can have 1 here, 2, we cannot write 2 again because 2 is already there. 3, yes, we can write it down. 4, yes. We cannot write 5 because 5 is already present. So this is the example, this is the solution for A union B. Next is A intersection C. For A intersection C, let's see what are the common elements between the set A and C. That will be the answer. So if we see that 2 is common in both of the sets, then again we will be having like 8 is also common. So this is the example. Only these two elements are common in A and C. Again intersection B intersection C, then we will be having 2 as common element and 4 here. Next we have A minus B. A minus B will be just write down all the elements that belongs to A only and does not belongs to B. So if we have firstly we have 2 is also present in B, so don't write it. 5, it is also present in B, don't write it. So the answer will be 8 and 10 because these two elements belongs to A only. Next is B minus A. So here we check set B. 1 we can write because 1 does not belongs to A, it only belongs to B. 2 we cannot write 2 here. 3 is again only belongs to B only. Then 4 also we cannot write 5 because 5 belongs to A also. Next is your A union B minus C. We already have A union B and we know the C. So let's start with A union B. Just remove all the elements from A union B which are also present in C. So 2 is present, we cannot write 2. 5 we can write 5. Then 8 is also present in C, so we cannot write. Then check 10. Yes, we can write 10 here. 1, okay, 1 we can also write it down. 3 is also not present in C. 4 is present in C, so we cannot write that. So this is the solution for this particular question. Again, now let's have A intersection B union C. So the first thing that we need to write is B union C. We need to know B union C will be 1, 2, 3, 4, 5. Firstly all elements of B, then check for C also. For C 2 is already present, 4 is already present, 6 and 8. So this will be the B union C. Now take the this union with intersection A. So now here let's see what are the common elements here. So here we have 2 is present, 5 is present, 8 is present. So this is the solution. Again let's check A intersection B. Let's find out first A intersection B. A intersection B is we have 2 in common and 5 in common, only these two elements. Then just firstly we write 2 and 5 and we see that just remove those elements which are present in C. So just remove 2 from here. We are having only 5 in this case. Now let's solve another question. A intersection B complement. So the complement will, if A intersection B is 2, 5, then its complement will not have these two elements and rest it will have all the elements. So it means all the elements of U minus these two elements, right? And union it with C. So let's have all the elements of universal set. That means 1 to 10. 1 will be the 1 will be there. 2 does not belongs to A intersection B complement. Then 3, 4, 6, 7, 8, 9 and 10. And union it with C. So the C with C we are having 2 also because 2 is present in C. So this is the solution for it. Next, union of all the 3 sets. So just write the first set. Firstly 2, 5, 8 and 10. Then second set 1, 2 is already there, 3, 4 is 4 and 5 is already there. Then check for C, with start with C. 2 is already there, 4 is there, 6 is not there, and 8 is already present. So this is the union. Again check the common elements between all the three sets. So here we are having 2 is present in all the three sets, and next we don't have any other element that is common in all the three, so the answer is 2 only. Next is your A intersection B minus B intersection C. So we will be having B intersection C already here, and just A intersection B we already know. So A intersection B is 2 minus 2 comma 5, and remove the elements that belongs to B intersection C. So 2 belongs to B intersection C and 2 belongs to A intersection. So don't write 2 here. So the answer will be only 5. Next is your A union B minus C minus B. So firstly we need to find C minus B. What is C minus B? C minus B will be just only write those elements that belongs to C only. So 2 belongs to both, 4 belongs to both, 6 belongs to only C, and 8 also belongs to C only. So now let's write down all the elements of the first set first. So 2 is there, 5 is there, 8 belongs to C minus B if we can see. So don't write 8 here. Again write 10 from the union. 1 we can write, yes. Wait a minute. 1. Then we will be having 3. Yes, we can write 3 and 4. Now A intersection with its complement, it always result in phi, because there will be no common element between the A and its complement. B union B dash, it will always result in universal set. That means 1, 2 till 10. So this is how we solve these questions. Coming on to the last question, one of the last question. Here we need to prove A minus B minus C equals to A minus C minus B minus C. So again the first step will be just take an element that belongs to the LHS and open up the brackets. So we know this minus will be that X belongs to this, but X does not belongs to this. So we just open up this, that X belongs to A minus B and X does not belongs to C. Open up this bracket also. So X belongs to A and X does not belongs to B, and and this will be written same here. Now just leave this part here only and start taking that X belongs to RHS. If X belongs to this, then X belongs to A minus C, and because there is a minus sign, so X does not belongs to B minus C. Now just open up the bracket. X belongs to A and X does not belongs to C. X belongs to B, X does not belongs to B. And we don't need to write again that X does not belongs to C, because it is already present in here in this step. So from first and 2, because both are the same, we can say that LHS is equal to RHS. Now let's solve another example. Okay, so in this example we have in a class of 25 students, that means total students are 25. This is given. Then 12 have taken maths. Let's say M is a set that represents students taking maths, and B is a set that represents students taking biology. So 12 have taken maths, that means NM is 12. 8 have taken maths but not biology. What does it means? That N maths, they took maths but not biology. So M minus B is also given, which is 8. Now find the number of students who have taken maths and biology. That we know that number of students that have taken maths and represents intersection biology. So firstly we need to find this. Secondly, find number of students those who have taken biology but not maths. That means B minus M. We need to find these two. Here the total students, that means M union B is given 25. Now apply some of the formulas from set. So we know that M union B will result in NM plus NB minus NM intersection B. Here just replace these with values. 12 plus NB, we don't know NB. Okay. And we also don't know NM intersection B. So, but we know this 25. Stop it here because we don't know the two parts. Let's start with NM minus B. M minus B will be equals to NM minus NM intersection B. Here we know M minus B is 8, NM is 12 minus NM intersection B. So the result will be NM intersection B is 12 minus 8. So the answer for intersection is 4. So we got our first part answer. Now just replace it with in equation first. So here 25 equals to 12 plus NB we don't know. Next we have M intersection B with 4. So NB will be equals to 25 minus 8 and this will result in 17. So NB is 17. Now we need to find NB minus M, which is equals to NB minus NB intersection M. We know NB here 17 minus A intersection is 4. So the answer is 13. So this is our second part answer. This is how you are going to use formulas that I have told you in the first 5 minutes to learn these formulas. I hope this lecture is useful to you. Thank you.